Up next, we have Tim Cowman. He's our state geologist and program administrator for the Geological Survey Program out of Vermilion. And he's going to talk about the new statewide groundwater quality monitoring network information system. So with that, Tim, I turn it over to you.
Okay, I'm going to talk today about the statewide groundwater quality monitoring network and some new activities that we have going on with that network, as well as how we're trying to make the vast amount of information this network generates easier for people to access. So first I want to give you just an overview of what the network is. A lot of you out there, I'm sure, probably have seen this before in prior presentations that myself and my staff have given. But I'll just give you a brief overview of that, as well as talk about increased monitoring efforts that we initiated in 2019 and 2020, and then also show you a new online interactive map that we've built to disseminate the data and the results from this network. So an overview of the aquifers that we monitor in this network. It's about 25 of shallow aquifers across the state of South Dakota. And we have 144 wells distributed across those aquifers. So you can see the aquifers in the colors here, and the names of those aquifers are shown next to the colored polygons, and then the red dots represent where we have our monitoring sites at in each of these networks. The purpose of this network is to monitor the present quality of shallow groundwater resources in the state, also to examine short and long-term trends in the water quality of those aquifers. The sites were selected to be representative of typical land use over the aquifer, and also to avoid point sources of contamination. In terms of the operation of the network, we sample the network for common inorganics, including nitrate, ammonia, and phosphorus, and also for pesticides. And we sample half of the network each year. We used to sample the entire thing each year, but due to the budget constraints, we had to cut back and only sample half of it each year now. So a typical well in the network looks like what you see on the left part of your screen here. It's basically a PVC casing with a screen at the bottom of it. Inside the well is a dedicated stainless steel pump, and with control or access ports at the top of the well. This allows us to pull up to the well and with pump equipment, we're able to connect to these ports, turn the pumps on, evacuate the proper number of well volumes, and then fill our water sample bottles. By having the dedicated pumps, we are not only able to sample the network more efficiently, but also eliminate the chance for cross-contamination of chemical constituents between well sites. Typically, most of our sites out there have two wells at them. We have a shallow well and a deep well, like is shown on the right side of the slide here. And the reason for that is because we found that some chemical constituents, nitrate in particular, tend to stratify in the upper part of the water table. So we're sampling both the upper and the lower parts of the water table to make sure that we're not missing any chemical constituents that might stratify. The typical monitoring site location looks like this, just sort of out in the middle of nowhere along a county road somewhere. So it's away from point sources of contamination, you know, away from being directly next to a farmstead or next to a city or anything like that. Really, the main thing that's around most of these sites is just your average agricultural use land in South Dakota. This is a picture of what a typical monitoring site looks like. You can see we're actually in the road ditch right of way here, and there are two wells sticking up one in the center of the screen and one toward the right of the screen. You can see the yellow well protectors with locking caps that are on those wells, as well as fence posts to help protect the well protector from being hit by machinery or other things like that. To sample the well, we generally just pull into the ditch with our sampling vehicle, which currently is this white Ford pickup with a customized topper on the back with all the sampling equipment in it. We can get close to the well and collect our samples that way. In terms of the kinds of results we've been seeing, and first of all, I should say that the majority of the sites for this network were put in back in the 1990s. So we've been collecting data anywhere from 25 to almost 30 years for many of these sites, and really have a wealth of data on what the water quality trends are in these aquifers. But that doesn't make it any easier to make sense of what's happening out there, because we have almost everything that you can imagine going on out there. Here are the 4 typical examples. Here's a site out of the Tulare Aquifer, and here we have nitrate values, which tends to be the constituent of most concern out there. We have nitrate values that are staying pretty low. So the MCL of 10 parts per million is shown with the red horizontal line there. You can see that over the years since 1997, the values have stayed pretty low, definitely in the single digits at that site in the Tulare Aquifer. Here's another site from the Tulare Aquifer, which would be maybe 10, 15 miles away from the original site we just looked at. But here we have nitrate values in the shallow well that were pretty high back in the 1990s and the 2000s. They were between, generally around 20 to 25 parts per million. But then by the time we started to approach 2010, the nitrate values started to lessen, and now they're hanging right around that 10 part per million part. So it's an example of a site we have out there where historical values have been high in nitrate, and now they've gotten lower. Another site showing just the opposite. This one is in the Vermilion East Fork Aquifer. I believe this is up in Clark County, South Dakota. Here we started out with low nitrate values, and then around 2010, the nitrate values got fairly high and were hanging for several years up around 20 parts per million. And now, though, they've dropped back down to around that 10 part per million level. And then finally, we have sites like this. So here's a site in the Big Sioux Aquifer in Brookings County, where the nitrate values have always been between 20 and 30 parts per million, and it rarely deviates from that. So basically, it's unique situations at many of these sites in many of these aquifers. Because we have had some, there's quite a few sites out there where we've seen high nitrate values. In 2019 and in 2020, we implemented a program to go back to those sites and sample them intensively during the growing season to see if we were seeing any fluctuations, whether it's lows or highs in nitrate values over the months of the growing season. So basically, all the sites, the red dots you see in red here, are sites where at some point in the last 10 years, we've seen more than 10 parts per million coming from that aquifer at that site. And so those are the sites that were picked up in this intensive sampling program. The other dots that are green there are sites where in the last 10 years, we have not seen values over 10 parts per million for nitrate concentrations. And so they were not intensively sampled. We just stayed with our regular every other year sampling routine at those sites. So I'm not going to show you all of the graphs, and we're just starting to analyze the data, but here's a couple of typical results we've seen through that high intensity nitrate sampling. Here is a site in Brookings County in the Big Sioux Aquifer that you can see from 1994 up through 2020. it's typically had nitrate values between 20 and 30 parts per million. So it's just a perpetually high site. What we wanted to do is see if, because we only are sampling it basically every other year now, and just once, we wanted to go in and sample it on a monthly basis, starting with the growing season, to see if we were seeing any major fluctuation in the nitrate in the groundwater at this site. And what we found, if we look at this, you can see the samples that we took in June, July, August, and September of 2019. And again, with samples that we took, turn on my laser pointer here. So here you can see there's a dot everywhere we took a sample in 2019. There really was no fluctuation. They stayed high, just above 30. And then coming to 2019 or in 2020, we took samples in May, June, July, August, and September. And again, no real substantial fluctuation. So that there's something going on there, that site is high from year to year, as well as within the year itself, we see no major fluctuation in the nitrate values. If we move down in the Big Sioux Aquifer down to Moody County, just below Brookings County there, here's a site that we have in Moody County. And you can see since this site was put in 1994, the nitrate values have been kind of bouncing around. Sometimes they're below 10, sometimes above 10. And then over the last 6 or 7 years, they've definitely just been kind of hanging right around that 10 part per million mark. So if we go in and look at what the intensive sampling showed at that site, here we do see some kind of a trend happening, but it's not the same each year. So in 2019, we sampled monthly starting in June, and we saw a ramp up in the nitrate values from 3.3 to a peak of 16.7 in August, and then they dropped back off at the end of September when we went in and sampled it again. Now, if we look at what happened at that site this year, though, the nitrate values started out fairly low in May, around 5 parts per million, and then they just continually dropped off each month over the course of the growing season. The last sample that we took there in the middle of August, the nitrate values were only 1.3 parts per million. So I would say, in looking at those intensively sampled nitrate sites that we've done, though, this is definitely the exception. The norm has been more like that first graph I showed you from Brookings County, where whatever it's been doing over the last 20 years or so, that doesn't really change much over the course of the growing season. It just kind of stays at that level. But there are a handful of sites where there is obviously something going on that's influencing the nitrate values over the course of the growing season. And that doesn't necessarily mean that we're seeing spikes and then drop-offs like we did in 2019, because in 2020, we're just simply seeing a drop-off over the course of the growing season. As you can imagine, there's a ton of variables that we need to look at here. And those are things that we're in the process of looking at. And that includes what are the land use patterns going on, around the vicinity of this site. Also, what kind of precipitation patterns have we had? Are we having like huge rain events that might be flushing stuff, or has it been dry like this year, and so on? And so 2019 and 2020, as you've heard from the previous talks, were really 180 degrees difference in terms of climate. So in this area, we had just a ton of water come down as precip in 2019, huge rain events. But in 2020, it's been relatively dry in that area. So we've got to factor that in, as well as the land use and what might be happening naturally as well in the aquifer system. So those are some of the results of what we've got here, and some of the things that we're looking at. I did want to show you those, a new online interactive map that we've just released for this monitoring network that helps us disseminate this information to everyone else out there, whether it be other agencies or the general public. People can go in and see what our monitoring results are in this network. So in order to get to this map, there's a couple of ways you can do it. You can go to the South Dakota Geological Survey's website, which the address is on the top of this slide. Or you can also, if you're familiar with DENR's online GIS map gallery on the DENR website, you can go there as well. They'll both get you there. But if you go through the geological surveys from the home page, you just click on online interactive maps, and one of them that you can pick from will be this statewide groundwater quality monitoring network. So I'm going to just go directly to the website now and show you some stuff live. David, are you still seeing my screen okay?
Yep.
Okay. So I'm actually live on the website right now on the interactive map. And first we see a map of the aquifers, and then shown in the colors, and then also red dots wherever we have a monitoring site. So there's two different ways to look at the data. One is to look at it by aquifer, what's happening in the aquifer in general, and the other is looking at what's happening at a particular site. So first I'll just zoom in down here to Turner County, and we've got a nice little aquifer there called the Parker Centerville Aquifer. And so if I want to see what's going on in that aquifer, I can just click on it. And the pop-up window there tells me we have 3 sites in that aquifer. And if I click on the statistical data link, that's going to bring up a PDF, which will show me where the sites are, and then a summary of the data from those sites in that aquifer. So you can see basically we've got sites concentrated between Parker and Davis in that aquifer. And if I scroll down to the next page here, here is the statistical information that we've generated over the years from that aquifer. So let's just look at, start with the nutrient section, look at the nitrate. So we've got 191 samples, groundwater samples that we've analyzed for nitrate from the Parker Centerville Aquifer. The mean or average concentration is 2.2 parts per million. But then we've run additional statistics further to the right here. You can see basically at the 75th percentile is 3.6. So 75% of the samples or analyses show 3.6 or lower. And then the highest concentration that we saw in those 191 samples was about 24 parts per million nitrate. Then also in the comments, this I think is an interesting statistic, and you can look at this through all of the aquifers. But in this particular aquifer, 7 of those 191 samples exceeded the MCL of 10 milligrams per liter. And that's actually relatively low. On a lot of our eastern South Dakota glacial outwash aquifers, we're running about 20 to 25% of the samples exceeding the 10 MCL limit. There's a lot more information on major ions, trace elements, and so on, but I also wanted to point out the pesticides section. What we did there was we only reported the pesticide detections. So every pesticide that had a detect in the Parker Centerville Aquifer over the last 25 years is shown in this table. And you can see there's 6 of them. So just take the first one, allichlor, and I don't believe that's even being used anymore, but it was at one time when we had the network going. We had one detection in the whole life of the network for allichlor, and since there's only one, the min and max are the same, which was 0.117 parts per billion. The MCL is 2 parts per billion. Atrazine, if you look on the third line, that's one that we tend to see a lot in the aquifers. We've had 3 detections over the life of the network in the Parker Centerville for atrazine, ranging from 0.1 to 0.21 parts per billion, well below the MCL of 3 parts per billion. And that's really what we find in all of the aquifers with all of the pesticides, is that although we have a handful of hits from time to time, except for a couple of instances, it's always under the MCL when we see those hits. So if we go back to the map now we can actually look at a site and see what that shows. So I'll just zoom out and we'll go to a different aquifer. So I'm gonna go up here into Kingsbury County, and we got that red dot there in the Vermilion East Fork Aquifer right here, which is, if I zoom in a little bit, you can see that it is site VE2 just north of DeSmit. So this time I'll click on the red dot instead of the aquifer, and now I get information about that monitoring site. And I can see there's 2 wells at that site. If I click on the well diagram information, it shows me precisely how those wells are constructed, how deep each well is, and where the screened interval is for each well. I'll go back to the map, and this time I will click on the data graphs. And now what I'll get is a PDF file that shows me graphs of 4 parameters for that particular site. So this is since the site was put in 1997. You can see in both the deep and the shallow wells what the ammonia concentrations have been doing. You can see what the nitrate concentrations are doing. So you can see for the most part it's been low, but then it got kind of high starting around 2010. And now it's getting back down below 10 parts per million with the latest round of sampling we've been doing. You can see a graph of what the phosphorus concentrations have been doing there at that site. They've been staying relatively low. And also the total dissolved solids, which is a general indicator of the water quality of the aquifer, has also been staying pretty good, around 400 parts per million. So that is kind of just a summary of some of the new activities we have going on with that network and how you can access that information. David, if we have any time for questions, I'd be glad to take any that are out there.
Yeah, we've gone over and we're getting into Troy's time here, but you do have some questions. If you can just hit them real quick here, so we can get on to Troy's presentation. One is, what is the cost to monitor all 144 wells each year?
Generally, $75,000 to $80,000 if we do all of them each year.
Okay.
And that's strictly analytical costs at the laboratory.
Okay. Jay's question, I think you kind of answered during your talk, so we'll go past that one. Last question, do you supplement your sampling at the observation wells with sampling from domestic wells completed in the same aquifer or any other type of wells?
We haven't been, because like I said in the beginning, the site here is designed to be, number one, very clean wells, very clean equipment, so there's no cross-contamination. And also the site selection is meant to be away from farmsteads, away from cities and so on, so that we're only looking at general land use and not impacts from what might be going on directly at a farmstead or a city. And then the other thing too is with the private wells, we often really aren't sure of the integrity of the construction of that well. So we don't know if, for example, they're getting some leakage from the surface down the annulus of the well that might impact our results.
Okay. Okay. Thank you very much, Tim. And any other questions, you can get a hold of Tim.